Now that you've learned how to find a minimum and a maximum, we can now start to apply those calculus concepts to real life situations. At the end of this lesson, you'll be able to use calculus concepts to solve optimization problems. Right, in an optimization problem, we're basically trying to maximize profit or minimize the amount of material that we're going to use, or minimize cost, different things like that. So in order to do that, the same way that we're going to find a minimum or a maximum, usually we're given an equation, but in a real situation type, we usually have to find the equation that we're going to minimize or maximize. And then from there, basically, if you remember to find a minimum, we find the critical number. So this is exactly what we'll do. In order to find a critical number, we'll need to take the derivative, and then we'll find that critical number. And that critical number will be our maximum or minimum. So let's go ahead with, these are, the first two that I'm going to start with are not super real life at all. It's just getting us used to the concept of working with mins and maxes. Okay, this one says to find two positive numbers such that the product is 192 and the sum is a minimum. Okay, first thing that I'm going to do on this problem is we want the sum to be a minimum, so I'm going to circle that, because our first step is to actually find an equation that we want to take the derivative of. So I would like the sum to be a minimum. So I'm going to write an equation for the sum. So I'm going to put S equals. If I have two positive numbers, I have absolutely no idea what those numbers are. So I'm going to call those two positive numbers X and Y. So if I need an equation for their sum, my equation would be S equals X plus Y. Okay, now you notice in this problem, if I were going to take the derivative of this, I actually have two variables, which is going to cause problems for me because I will have to use implicit differentiation, but instead I'm going to use some of the other information in the problem to help me out. They did tell me that the product of the two numbers was 192. So since my two numbers are X and Y, I'm going to do a little side trip here to help me with some information. Okay, my side trip is that the product, X times Y, will equal 192. And then from here, I could either solve this equation for X or Y. I'll go ahead and solve it for Y. So I'll divide both sides by X. So I'll get Y is equal to 192 over X. Now what I'm going to do actually is substitute that back into my equation before I take the derivative. So I'm going to have S equals X plus 192 over X. Now that I just have one variable in my problem, it will be easier for me to take the derivative. Before I take the derivative, though, I am going to rewrite this as X plus 192x to the negative 1. Right, I am now ready to take the derivative. So S prime, the derivative of S, will equal the derivative of X is 1, and then the derivative of this part, if I bump my negative out front, I'll have minus 192x to the negative 2. And if I were to rewrite that, I'll get 1 minus 192 over x squared. And if we found the derivative, the next thing that I would want to do is get a critical number, so I'll take that and I'll set it equal to 0. I think most people from here, actually there's probably a couple different ways to work this. You could either get a common denominator right now, which I think most people are doing, so I think that's the approach I'm going to take right now. So I'd have to multiply this top and bottom of this one by x squared, so I'm going to get x squared minus 192 over x squared equals 0. And if I'm looking for a critical number, I'd look for the numerator and denominator. So if I set that numerator equal to 0, I'll get x squared minus 192 equals 0. I'll add 192 to both sides, so I'll get x squared equals 192. And then I have to take the square root. And normally I would put a plus or minus in front of this, but I'm not going to put a plus or minus in front of it this time because we're talking about, it said to find two positive numbers, so we would stop right there. And then another critical number, if I was looking at this, would actually be where does the denominator equal 0? The denominator equals 0 at x equals 0, but again it said to find two positive numbers, and 0 is not a positive number, so I'll just cross it off. Okay, so notice I found x. My next thing is I would like to find y, so I'll go back up in here and plug it in. So y will equal 192 divided by the square root of 192, which is just kind of crazy. You can either leave your answer like that, which would be fine, or I'm going to rationalize it. I'll multiply by the square root of 192 over the square root of 192, and I'll end up getting 192 square root of 192 over 192. Those cancel, and I just get the square root of 192. So even though it never said that we had to have positive whole numbers, so those are kind of messy numbers, but they are numbers. So it said to find two positive numbers. I will just say the two numbers are square root of 192 and square root of 192. So I found my two numbers that would create that maximum. Alrighty, let's try another one. This time, again, not real life yet, but we're just going to keep working into it. Find two positive numbers such that the product is 192 again, and the sum of the first plus 3 times the second is the minimum. So I'm going to circle what I want to find the minimum of. I want to find the minimum of the sum again. Okay, and here I'm looking for, again, two positive numbers, so I'm going to call those positive numbers x and y. So first thing I want to do is write an equation of what I want to find a minimum of. So I'm going to put s equals, because it's a sum. It says the sum of the first, well, let the first number be x plus 3 times the second. Okay, so that's my formula. Again, there are two variables, and I really want only one variable before I take the derivative. So again, I'm going to come over here and do a little side trip. So it says the product is 192 again, so we'll do xy equals 192. And then from here, this time I think I'm going to solve for x. And then if I do that, I'll get x equals 192 over y. So then again, before I take the derivative, we can plug that in. So I'm going to get s equals 192 over y plus 3y. And before I take the derivative, let me rewrite this. This will be 192 y to the negative 1 plus 3y. Now I'm ready to find the derivative. So if I find the derivative, my derivative will be negative 192 y to the negative 2 plus 3. And even though there is a y, since there's only one variable, I don't have to put dy dx. So we've taken the derivative, that's what I've gotten, and then from here I'm going to rewrite it. So I'll get negative 192 over y squared plus 3. And then from here we will set that equal to 0 to find our critical numbers. Again, I'm going to get a common denominator, so I'd multiply the top and the bottom of the second one by y squared. So I'll get negative 192 plus 3y squared over y squared equals 0. Again, first of all, I'll set the numerator equal to 0, so I'll get negative 192 plus 3y squared equals 0. I'll add 192 to both sides, so I'll get 3y squared equals 192. I'll then divide both sides by 3, which will give me 64. And then to get rid of the square, we'll take the square root. And again, I'm only going to put the positive square root because we need positive numbers. And again, critical numbers also occur where the denominator would equal 0. But if I square rooted both sides, I still get y equals 0, and that's not a positive number. So one of my positive numbers is 8. And now to get my second number, I'm going to go back up to this equation right here. I'll get x equals 192 over 8, and when I divide that out, I'll get x equals 24. They are both positive, and when it said to find two positive numbers, I can now say the two numbers are 8 and 24. And there we go, we found those. Right, the next one, a rectangle is bounded by the x-axis and the semicircle y equals the square root of 25 minus x squared. What length and width should the rectangle have so that its area is a maximum? I do believe you have a picture on yours, so I'm just going to draw my picture here real quick for me. And there's my rectangle, and then I just called this the point xy. Okay, so it says what length and width should the rectangle have so that its area is a maximum. So we need a formula for the area. So I'm going to put area equals, this is a rectangle. The area of a rectangle is length times width. So now I just need to figure out in terms of x and y what the length of that rectangle is and what the width is. All right. You'll notice on this one, x goes from 0 over to here. So that's x. So if I want the length right here, this would actually be 2x. So my area is going to equal 2x, and then my width is just going to be y. And again, you'll notice I have two variables, so it would be very nice if I only had one. I do notice up here that I did tell you what y was. So we can take this right down here and use substitution and put that in for y. So from here, we will get the area is equal to 2x and then square root of 25 minus x squared. All right, now from here we found the area formula. There's only one variable. Our next thing to do is to find the critical numbers, which would be to start by taking that derivative. Okay, before I take the derivative, I'm going to rewrite this as 2x and then This will be 25 minus x squared to the 1/2. And I do notice on this one it's going to be a little bit messy, but we can handle it. What I'm going to do on this one is, it is a product, so I am going to have to use the product rule. Okay, f prime will equal to, pretty simple. To get g prime, notice that we have something in parentheses, so I actually need to rewrite this. It's a chain rule problem, so I'll call this u to the 1/2. So when I take the derivative of u to the 1/2, I'll get 1/2 u to the negative 1/2 times the derivative of what's inside, and the derivative of what's inside is negative 2x. So if I simplify that, I'll get 1/2 times negative 2x, which would give me negative x, and then it's going to be over u to the positive 1/2, so it'll be the square root of u, which is the square root of 25 minus x squared. Okay, so now I've done all that just so I can get a prime. So this will be f prime times g, so 2 times the square root of 25 minus x squared, and then plus f g prime, so 2x times negative x over the square root of 25 minus x squared. And then let's see if we can clean that up a little bit here. So I'm going to get 2 square root 25 minus x squared minus 2x times negative x will be minus 2x squared over the square root of 25 minus x squared. And what I'd like to do with that is, now if we're going to find the critical number, we'll set that equal to 0, and this just looks like a huge mess, but I think that we can make sense of it. Just like I did in my other two problems, I'm going to get a common denominator, which will be the square root of 25 minus x squared. So I'm going to multiply the top and the bottom by the square root of 25 minus x squared. When I take the top, this square root of 25 minus x squared times 2 square root 25 minus x squared, the square roots are going to drop out, so I'm going to be left with 2 times 25 minus x squared. And then minus, I don't have to do anything with that second fraction. And then it will be all over the square root of 25 minus x squared. And then we still have this equal 0. I'm going to work this out just a little bit more. I'll get 50 minus 2x squared minus 2x squared all over the square root of 25 minus x squared, still equals 0. Simplifying the numerator, 50 minus 4x squared and setting it equal to 0, I will add 4x squared to both sides, I think. And then I will divide by 4. So x squared equals, I believe, 12.5. And then x, I'd have to square root that, so x equals the square root of 12.5, which is 3.536. And we will use our calculator on that to get that. So x is equal to 3.536. Okay, are we done? No, because I need to figure out what y is. Oh, and actually, if I would have gone up here, we would have gotten x equals 5, which would have actually brought me over here, and I wouldn't have a rectangle, so we didn't have to worry about the denominator in that problem. Okay, so we got x equals 3.536. I'm going to come back way up here and plug my x in, so I'm going to get the square root of 25 minus 3.536. And then if I figure that out, that will also be 3.536. So when it says what length and width should the rectangle have, length was equal to 2x. So our length is actually going to be 7.072, and then our width is going to equal the 3.536. Okay, so mostly notice that getting it set up was not the hard part. It was really all the algebra in between to getting to our answer. Hopefully now you can solve some optimization problems.